Hello students. So I'll explain the failure of Cotter joint. Cotter joint. Okay. So in a Cotter joint we have three parts, that is socket and cotter and spigot. Since I have already explained how they look like and how they are connected to each other to make an assembly. Okay, so today we'll look at how they fail. Now you see, as cotter joint is used to connect two rods. Now this is one rod which is circular, another rod is there. Now we want to connect them somehow. That means join them together with some temporary joint, and once we join them we can pull the rods, okay, and the joint will experience the stress, right? There will be some joint between these two rods, okay, and you can also compress them. Then also the joint will prevent, anyway compression and tension both will be prevented by the joint. Okay, now we'll see there is a type of joint, it is called cotter joint, right? So how to make that cotter joint? Okay, so have a look at this. So for this rod we just enlarge it a little bit, okay, enlarge it like this, okay, and then we have increased this diameter and we'll further increase the diameter a little bit more, okay, here at this point like this. Okay, finish. Fine. Now this will be drilled, or boring will be done, bored, to make a hole here. We'll see that thing later. Now for this rod, okay, this rod also will make one small, you can say, ring like structure here, okay, and this side will be again made that will be kept at a diameter, okay, at some diameter which will not be the same as the diameter of this rod, okay. This diameter will be different, okay, this one. So alright, now we will make this rod this side. If you view from this side, view from this side, okay, then look at this. This is, we have just reversed the sides, okay, and this is 180-degree rotation, complete rotation we have done, and now we will bore this side, okay. We will make a hole. Let's say this diameter is T2. This part is called spigot, okay, this part is called spigot, okay, this is called the spigot, and this diameter is, let's say it is D2, okay, and this is, now we will drill it with equal diameter of that is D2, okay, and this diameter and this one will be actually greater than this D2, okay, so that this will be bored until a distance, okay. So that distance is actually is up to you, okay. Normally a suitable distance is taken. So this is a hole that has been made, okay. Now after that what we do, from the top, if you view now top side, okay, so it will look like this from the top. You know the views, right, all of you? So since you already know from machine drawing, you have known. Now from the top, if you see from here if you see, okay, from here, right, like this, then you will view it here top side. So this will look like a what, rectangle? All of them will look like a rectangle, right? So now here we will drill it, okay, we will make a drill. sorry, actually this is not a drill, this is a slot, we call slot. Okay, so we'll make a slot and we'll actually kind of make it empty, this space. Okay, so that it will look like, I mean it will just dig it like this. Okay, not here. So ultimately there will be a gap here. Okay, like this. From, I mean you can see the your slides and the picture here. So then this slot will be present throughout. Okay, now in the spigot also we will make it here, and then we will insert the spigot, this part will insert here, because this is diameter d2. Okay, this diameter is d2, this diameter is also d2, they will match together, so they will be inserted. So the spigot will come inside this spigot part, they will come, the spigot part, this is the spigot I am showing. Okay, and they will come here, and this ring like structure will match so that the spigot cannot go further inside. And now this is the rod. Okay, understood? So socket and spigot has been joined. Now we have matched their slots. Now the third part, that is the cotter. Cotter looks like this. Okay, this is the cotter. Okay, now this cotter will go inside this slot. Now this thickness of the cotter, this thickness T, is equal to this thickness of the slot. Okay, thickness of the slot. So that's why the cotter will go inside this thing. So ultimately the cotter will join them together. Okay, so the diagram looks messy, but like you have understood this, I think. Okay, so now there is a diagram. The diagram, to save time, I am showing you directly from the book. Okay, this is the diagram, right? So here you already know that it's their dimensions. Okay, now you see this is the complete spigot part. Okay, and this is your, sorry, this is the socket part and this is the spigot part. Okay, so your socket will be, socket is being pulled in this direction. Okay, and spigot is being pulled in this direction, right? So you see, if you draw a free body diagram of the socket, right, so it will look like this. See, so here is the socket part, right? So you're pulling it like this, so this will apply forces on the cotter here and here. Okay, these 2 points, right? And similarly we have the spigot which is being pulled in this direction. Okay, and cotter is present here again, and cotter will experience a force in this direction. Okay, now have a look at the failure of the cotter. Now this is the cotter, right? Now if you draw the free body diagram of the cotter, then this is the cotter and it is experiencing forces like this. So this is the force which is P, that dimension force value is P, magnitude is P, and this is also P. So since the both sides are identical for this socket, this will be P by 2 and this will be P by 2. Okay, if you find it out, you can find out, right, using moment equations and taking moment along your center line, you will get it as P by 2 P by 2, and this is P. Okay, now there are two forces and this is force in the opposite direction. So if we consider failure or breaking of your cotter, okay, breaking of cotter, how will it break? Obviously it will break like this. So this portion will break here, the middle portion will be here, and this portion will go here, because this is being pulled by P by 2 and this is being pulled by P. Understood? So there are two areas under failure. Okay, both the areas have failed. Okay, like that. Otherwise, if one area has failed, other area is there still there, then Cotter joint is still in contact. Okay, it will still be possible. I mean, by the way, that is not possible, because if it separates, then both the side has to separate. Okay, so this is the failure of the Cotter. Now the area and all, see, you have I mean, that has been explained already. Okay, so how to find the area? See, this area here is the I mean, if you draw out like this, okay, this is the area, right? Isn't it? Failure area. Okay, right? So in that case, if we know this length, I mean length of this rectangle, and breadth is T, this thickness of the Cotter, right? So this is B into T is the area. Okay, similarly there is one more area. Okay, so the failure area for the Cotter is 2BT. Okay, right? Since shear is taking place, that's why this will be a shear failure. So we'll write it as allowable stress equals to applied force, that is the magnitude only. Actually reaction force should be the proper definition. Okay, so allowable stress is the magnitude of applied force divided by failure area. Total failure area we take. Okay, so allowable stress here is tau, applied force is P, failure area is 2BT. This is your formula for Cotter part, only the Cotter part. Okay, sorry. Okay, sorry for that. So continuing, next we have failure for your socket. So have a look at this. The socket can fail in this manner. Let's see, socket failure can happen in see, if suppose the socket breaks at this point, okay, this point, and this is how it will look like then. Understood? Okay, so this is the, because there is a hole here, this hole will be visible now because of the breaking. Okay, and this is the area that has broken. Fine. Now the thing is, this hole is not a complete hole, there is a slot. Okay, this slot is present, so there will be a slot present. Okay, yeah, a slot will be present here completely. Okay, so this is not the proper diagram. Okay, the proper diagram will be like, there will be a slot, so this is the empty space, and then we will draw it, and this is the area. Okay, fine. So this is the area, and here is your failure. Since this area is perpendicular to the applied force, right? So this is a tensile failure. So we'll write it as sigma, this force divided by this area. So we have to find this area, right? So if you find the area of the entire circle, okay, minus this area of the smaller circle, okay, minus area of these two small slots, then we'll get the area here. Understood? So that has been explained already, and how to get that one I'll explain in your class while taking the classes. Okay, next, this is one type of failure of your socket. Okay, another type of failure can be like, instead of breaking here, it may break like this. at this point. Okay, because the Cotter is touching it here, right? So it is like here. So at this point separation may take place here. I mean these two portions. Okay, if these two portions break, okay, come out, then also your failure may take place. Okay, so this area, because you see this is sometimes difficult if you cannot if you are unable to imagine it, and that's why I have given you videos to watch. Okay, because animated videos only can explain it the best way. Now this is the area that came out. Similarly there will be an area because the slot is present here also. Okay, right? So this is the area. Okay, so completely, I mean the slot was not present here actually. The small portion, this portion, it was connected, right? Because it is not present at the end, otherwise it will not be in position, right? So this small portion has come out, and this is that portion is this one. Okay, this is the length. Okay, this is the length. And here also similar part will come out. Okay, this is the area. There will be four areas in this case, and all the areas are parallel to the applied force. Okay, so this is what will be the failure areas. So since they are parallel to the applied force, so this is shear failure tau P equal to P divided by all the failure areas. Okay, so I'll explain the failure areas, their values, because if you know this one and this dimension, okay, then you can find one area multiplied by 4. Okay, you'll get the whole area, all the areas, 1 2 3 4, 2 areas behind. Okay, so this is the failure for the your socket part. Okay, there is one more type of failure, that is a crushing one, and that I will explain during your while showing your failure, crushing failure, that figure. Okay, by the way, this is not so important. Anyway, so next thing is failure of spigot. Okay, now a spigot can also fail in this manner, you see. So this is the slot. Okay, so this is the spigot. Now it can break here at this point. At this point, if it breaks, right, then it will be tensile failure, because you see it will look like this now. Okay, so there will be a slot here. So you understood this, I think. So this is the area that has failed. So this area looks like this. Alright, so now since the area is perpendicular to the applied force, okay, so this is sigma equal to force by this area. So this area can be found by finding out the entire area of the circle minus the area of your rectangle, this rectangular slot. Okay, you can find, then you will get this for the socket, that is the tensile failure of the socket, or spigot, sorry. Next, instead of breaking it here, it may come out because the this Cotter is present like this, right? So if Cotter doesn't break and socket breaks, then this will come out like this. Okay, here. So the failure will take place in this case, will take place like this. Okay, I mean here the entire portion of this thing here came out. I mean this was present here. I mean this is small part, this part I am talking about. Okay, this part has come out. Now the complete the slot is present. Okay, so because of that this has failed. Now this is the applied force P. Okay, and these areas are parallel to the force, so this is a shear failure, so tau equal to force by this area. Okay, if you know the length of this portion here, okay, like this portion has broken, right, and this is T, this portion is T, small t. If you notice length and if you notice length, then multiplying them to will give you the area of this part. Okay, there is one more area that side, so 2 into that area, 2 into the area of this one will give you the failure area. Understood? So crushing failure is also present in spigot, and that is not so important, so I will not talk about here. Okay, so I'll finish this video here. Okay, and we'll solve a numerical in the continuing video. Thank you.